Hello friends, we welcome you all to this video. Today, in this video, we are going to learn about the surface area of cubes and cuboids. Manas and Thomas are trying to fill some items in boxes. Look, I will make a cubic box and you make a cuboid shaped box. But how will we know how much cardboard do we need to make our respective boxes? Let us find the solution to this dilemma by mathematics. Hey, wow! That means it's math time! In the previous class, we studied the surface area of a cube. Do you remember its formula? Absolutely. The total surface area of a cube can be determined by the area of any one side of the cube, which is square in shape, L squared multiplied by 6, where L is the length of any side of the cube. And to find the lateral surface area of a cube, we can find the area of any one of its sides, L squared, and we will multiply it by 4. Absolutely right! And the length of the sides of my cubic box is 25 centimeters. Since we have to make a cubic box, to find the size of the cardboard used in it, we will have to find its total surface area. Let me quickly solve this by writing the length of the side of my cubic box, 25 centimeters instead of L here. In order to make my cubic box, I need cardboard of 3750 square centimeters. Hey, wow! Now it's my turn. We have studied that the total surface area of a cuboid can be determined by multiplying the sum of L times B, B times H, and H times L by 2, where L, B and H are the length, breadth and height of the cuboid respectively. And the lateral surface area of the cuboid can be determined by multiplying the sum of L and B by 2 times the height, H. In order to make the cuboid box, we will need all of its sides. So, the area of the cardboard that we will require is equal to the total surface area of the cuboid. Let me solve this by writing the length 27 centimeters, breadth 17 centimeters and height 10 centimeters in the formula instead of L, B and H respectively. Yes, I got it! For my cuboid box, we need 1798 square centimeters of cardboard. Yay! Now let us go back to our world and quickly buy the cardboard needed to make our own boxes. The two friends bought the cardboard together and made their respective boxes, which they filled with the scattered items. In this video today, we studied the surface area of the cube and cuboid. In the next video, we will see some interesting examples based on this. Hello friends, all of you are welcome to this video. In the previous video, we studied the surface area of a cube and cuboid. Now, in this video today, let us look at interesting examples based on the surface area of the cube and cuboid. The walls of your cuboid-shaped room seem to be very high. How tall are they? I don't know. Can we find it? Absolutely. We can find it by using mathematics. It is math time! Let's measure the length and breadth of this room. The length of the room is 12 feet and the breadth is 9 feet. Do you have any more information related to this room? Yes. It cost us 8,400 rupees at the rate of 10 rupees per square foot to paint the walls of this room. The area you painted for 8,400 rupees is equal to the total area of these 4 walls or the lateral surface area of this room. To find the lateral surface area of a room, we only have to divide this cost at the rate per square foot that you paid for the color. Therefore, the lateral surface area of this cubic room is 8,400 divided by 10 or 840 square feet. Hey wow, now it has become very easy. We know the lateral surface area of the room and its length and width are also known. Now we can easily find the height of this room in this way using the formula of the lateral surface area of the cuboid. After solving it in this way, we came to know that the height of the room is 20 feet. Wow! It is really very high. Come on, let us return to our world now. It is late for school. With this example, we have seen how problems in our daily lives can be solved by the surface area of cube and cuboid. In the next video, we will see some more interesting examples related to this topic. We welcome you all to this video. We have seen an interesting example in the previous video based on the surface area of a cube and cuboid. Today, in this video, we will see some more interesting examples based on this. What are you doing with this tarpaulin? I have to make a cubic structure with the help of this tarpaulin. That structure does not need to have any front and base surfaces. This will serve as a house for my dog. But I do not understand how much tarpaulin will I need for this. We can find the answer through mathematics. That means it's math time! Okay, tell me what will be the length of the sides of your cubical structure? About 32 inches. Assuming that the extra fabric of the tarpaulin used at the time of sewing will be negligible, the tarpaulin used in your cubic structure will need to have area of front face and base area subtracted from the total surface area of the cubic structure. Yeah, good. The formula for the total surface area of a cube is 6 times the square of the measurement of the sides of the cube. Let me quickly find the total surface area of this cubic structure by putting 32 inches as the side of this cube. Look, Thomas, by solving it in this way, we can see that the total surface area of your cubic structure is 6,144 square inches. Now, we just have to subtract the areas of the front and base area from it, and then we will get the size of your tarpaulin. both the front and base area are congruent. Therefore, their areas will be the square of the measurement of their sides. In this way, the sum of the areas of the two surfaces will be 2 times the square of the measure of the sides. The length of the sides of the structure is 32 inches. Let me solve it quickly by writing it here. Look, we got 4096 square inches of tarpaulin.
Yes, did you see how easy it is? Let us quickly return to our world. We also have to make the structure for your dog's house.
Both the friends together made a nice structure for Thomas's doghouse with tarpaulin. Friends, in this video, we saw another interesting example based on the surface area of cube and cuboid. So hopefully, by now you will have a good understanding of the surface area of cube and cuboid. Hello friends, welcome to this video. Today, in this video, we will study about the surface area of right circular cylinder. Friends, do you know what are right circular cylinders? Cylinders whose base is circular and whose curved part is perpendicular to its base are called right circular cylinders. Let us learn more about it in this video.
Thomas, your house smells very nice.
Yes, Mother has started a business of incense sticks. I'm helping her to pack incense sticks in right circular cylindrical packets of paper.
But how are these right circular cylinders?
The packet of incense sticks is a cylinder whose base is circular and the curved part is perpendicular to its base. So it is a right circular cylinder. But Manas, I have a problem. I'm not able to guess how much paper I will need to make a packet.
It is very simple. We can find this answer through mathematics.
Alright, that means it's math time!
Look, Thomas, the paper you use to make cylindrical incense stick packets will be used for all its surfaces. This means that the paper used to make a cylindrical packet will be equal to its total surface area.
Manas, we studied about the surface area of a cylinder last year. The total surface area of a cylinder with a radius r and height h can be found by 2 pi r times sum of r and h. And to find the curved surface area of cylinder, we will find the product of 2 pi r and h.
Thomas, what will be the height and radius of each of your cylindrical packets?
The height of each packet is 12.5 centimeters and the radius of its base is 1.5 centimeters.
Then, let us now quickly substitute the height of your cylindrical packet, 12.5 centimeters, and the radius of its base, 1.5 centimeters, in the formula of the total surface area of the cylinder. And then, solve this equation like this.
Look, Manas, because the paper used to make my cylindrical packet is equal to its total surface area, I would need 132 square centimeters of paper to make a cylindrical packet.
Well done, Thomas. Let us return to our world now. I will help you make this packet.
The two friends together made cylindrical incense stick packets and packed the incense sticks in them. In this video, we studied about the surface area of right circular cylinder. In the next video, we will see some interesting examples based on this. Hello friends! Welcome to this video. In the previous video, we studied about the surface area of right circular cylinder. Now, in this video today, let us look at interesting examples based on the surface area of right circular cylinder.
Manas, let's go play in the playground.
Yes, let's go.
Hey, what is this? There is some construction work going on the playground.
Yes, look how huge this road roller is. It is being used to level the playing field.
The area of the ground is 2,200 square meters. Then, how many rotations will this roller have to take to level the entire field?
We can find this very easily through mathematics. That means it's math time! Look, Thomas, when the roller completes one rotation, it flattens the area of the field equal to its curved surface area. Can you tell me the diameter and length of the roller?
The diameter of the roller is 70 centimeters and the length is 100 centimeters.
Now look, Thomas, we know that the curved surface area of a cylinder is the product of 2 pi r and h, where r and h are the radius and height of the cylinder respectively, which we can also write as the product of pi dh. In this way, the roller here is cylindrical and has a horizontal orientation. Therefore, the length of the cylindrical roller will be equal to its height here. Let me solve this by substituting the diameter of the roller 70 cm instead of d and length of the roller 100 cm instead of h in this formula.
Hey, wow! In this way, the curved surface area of the roller is 2.2 square meters. Now, what do we have to do, Manas?
Now it's very easy. Look, Thomas, in one rotation, the roller flattens an area of 2.2 square meters. So, in order to find the number of rotations the roller takes to level the entire ground, that is 2,200 square meters, we only need to divide the area of the field 2,200 square meters by the area of the field being flattened in one rotation, 2.2 square meters.
Oh, look! The roller has to make 1,000 rotations to level the playing field.
So many rotations! Then let's cancel the plan to play in the field today. Let us return to our world and go to my house and play a game.
With this example, we have seen how our daily life problems can be solved based on the surface area of a cylinder. In the next video, we will see some more interesting examples based on this. Welcome to this video. In the previous video, we saw an interesting example based on the surface area of right circular cylinder. Today, in this video, we will see some more interesting examples based on this.
Thomas, painter uncle looks upset. Let us go ask him why he is upset.
Yes, let's go.
Painter uncle, why are you upset?
Children, I got the job of coloring this pillar. I take 200 rupees to paint 1 square meter. But this pillar is cylindrical. Hence, I cannot figure out how much money I should take for coloring this column.
That's it, painter uncle. We can help you. We can find the answer to your problem through mathematics. Did you understand what this means, Thomas?
Absolutely. That means it's math time. Manas, to help uncle, we have to first find the curved surface area of this pillar. Then we can multiply it by the rate per square meter and find the total cost of coloring the pillar.
The height of the pillar is 3 meters and its diameter is 35 centimeters. Thomas, do you remember the formula for the curved surface area of cylinder?
Yes, Manas. The curved surface area of the cylinder is pi dh, where d and h are the diameter and height of the cylinder, respectively.
Well done, Thomas. Now we have to write the diameter of the pillar 35 centimeter in place of d and the height of the pillar 3 meter or 300 centimeter instead of h, respectively, and solve. On solving in this way, we can see that the curved surface area of the cylindrical pillar is 33,000 square centimeters or 33,000 divided by 10,000, that is 3.3 square meters.
Yes, Manas. And if we multiply this by per square meter rate of coloring, 200 rupees, in this way, you will find that 660 rupees would be the cost to paint this cylindrical pillar.
Oh wow, Thomas! Let us return to our world now. Painter uncle will be waiting for us.
Both the friends told Painter Uncle the cost of coloring the pillar, and Painter Uncle thanked them for their help. Friends, in this video we saw another interesting example based on surface area of right circular cylinder. So hopefully you will now have a good understanding of the surface area of the right circular cylinder. Hello friends, you are all welcome to this video. Today in this video, we will study the surface area of right circular cone.
Manas, today in school, we are organizing a party to celebrate Ramu Chacha's birthday. All the children are going to bring something or the other to the party. What are you going to bring?
I am thinking of making hats for all the people who will be coming to the party. But I can't figure out how much paper will I need to make each hat.
You can find the solution through mathematics. That means it's math time! Manas, can you tell me by what name is this shape of the hat better known?
I don't know, Thomas.
We call this shape of the cap a right circular cone. Here, Point A is called the vertex of this right circular cone. AB, its height, and BC is the radius of its base. And do you know something new? AC is called slant height of this cone. And here B is the center of the base, which is circular in shape.
I understood all this. But how does this relate to the paper used in my hats?
I'll tell you. See, if we cut this cone-shaped cap along any side or edge, going from the top of it and open it in this way, we will find that the paper of this shape makes the surface of your conical cap. In other words, the size or the area of this paper will be equal to the curved surface area of the cone. Correct?
Oh, wow! Thomas, this is very interesting. But there is a difficulty. We do not know the formula for the curved surface area of a cone.
Never mind if we don't know it yet. Let us find this formula. Look, Manas, the side where we cut the cone will be its slant height, which we will express with L. Now, if we divide the paper into hundreds of small pieces by lines going from O, then these sliced parts will look almost triangular in shape. And the interesting thing is that the height of each of these is equal to the slant height L of the cone. Look, Manas, each piece is in the shape of a triangle. So, can you tell me the area of each triangle?
The area of each triangle will be 1 by 2 times its base multiplied by the height, which is L here.
Well done. And see, the area of the entire paper will be equal to the sum of the areas of all these pieces. Now, if we represent the bases of all these triangles by writing B1, B2, B3, etc. respectively, then we can write the sum of the areas of all these triangles in this way.
But Thomas, B1, B2, B3, etc. together make up the outer part of this shape. So, the sum of all these will be equal to the length of the curved boundary of this shape.
That's absolutely right. And this curved part forms the base of the cone. And as we know, the circumference of this base will be 2 pi r, where r is the radius of the base.
Oh wow, Thomas! The area of the paper is equal to the curved surface area of the cone. So look, we get the formula for the curved surface area of the cone, where r is the radius of the base and L is the slant height of the cone.
And look, if we consider the height of the cone as h, then from the Pythagoras theorem, we can see that we can write the slant height of the cone in this way. And do you know, Manas, if the base of the cone is supposed to be kept closed, we will need a circular piece of paper with radius r to cover the base. The area of this circular piece of paper will be pi r squared. Now, if we add it to the formula for the curved surface area of the cone, then we will get the formula of total surface area of cone.
Let me quickly solve this by writing R and L in the formula for the curved surface area of the cone by writing the radius of the base of my cap as 5 centimeters and the slant height of the cap as 14 centimeters respectively. Look, Thomas, I would need 220 square centimeters of paper to make one hat.
Let us quickly write both these formulae in the formula booklet and return to our world. I'll help you make your hats, huh?
The two friends together made many hats and celebrated Ramu Chacha's birthday in a grand manner. In this video, we studied the surface area of right circular cone. In the next video, we will see some interesting examples based on this. Hello friends, we welcome you all to this video. If you remember, in the previous video, we studied the surface area of a right circular cone. Now, in this video, are you ready to look at an interesting example based on the surface area of right circular cone? Let's begin.
Look, Manas, it seems there is going to be a circus coming up here.
Yes, Thomas, I like the circus very much. See how huge this circus tent is. I wonder how much cloth they must have used to make this tent.
Haha, it's very easy to know. We can also find it out by mathematics.
Oh wow, that means it's math time.
Look at the tent, Manas. Can you tell me what shape is this tent?
The tent looks like a cone, so it's conical in shape.
You're absolutely right. And because this tent only uses fabric to create this curved surface, we can say that the fabric used in the tent will be equal to the curved surface area of the tent. Good, I remember the formula of the curved surface area of a cone. The curved surface area of a cone is equal to the product of pi r and l, where r and l are the radius of the base and the slant height of the cone respectively.
We can find the radius of the base of the tent by measuring from the center of the floor of the tent till the boundary of the tent. But tell me, Thomas, how do we find the slant height of the tent?
Don't worry, that is also very easy. Don't you remember that we can find the slant height of the cone by writing the measurements of the radius of its base r and the vertical height h of the tent in this formula?
Oh yes, and the height of the tent is equal to the height of the bamboo. Let me quickly measure the radius of the base of the tent and you measure the height of this bamboo.
The radius of the base of the tent is 24 meters and its height is 10 meters.
Okay, let me quickly solve this problem by writing these values in this formula instead of r and h respectively. Look, Thomas, the oblique or slant height of the tent is 26 meters.
Hey, wow, Manas. Let us now use the radius of the base of the tent, 24 meters, and its slant height of the cone, 26 meters, that we just found in the formula for the curved surface area of this cone instead of R and L respectively. Let's see what we get.
I got it! The curved surface area of the tent is 1961.14 square meters. This means that this tent is built using 1961.14 square meters of cloth.
Wow! So much cloth was used in making this. No wonder it is so huge. Now let us return to our world. The circus is just about to begin and we don't want to miss it.
The two friends together enjoyed the circus very much and returned home happily. With this example, we have seen how some of our daily life problems can be solved based on the surface area of a right circular cone. In the next video, we will see some more interesting examples based on this. You are all welcome to this video. We have seen an interesting example in the previous video based on the surface area of right circular cone. Today, in this video, we will see some more interesting examples based on this.
Thomas, the heat these days is really scorching. Let's go to eat ice cream.
Yes, let's go.
Thomas, look how beautifully this ice cream has been packed in colorful paper.
It's really beautiful, Manas. I wonder how much paper does it take to completely cover each ice cream like this?
Aha! We can find the answer through mathematics. That means it's math time! Thomas, can you tell me what shape this ice cream is?
I guess this ice cream looks like a cone.
That's right. And look, Thomas, this ice cream is completely covered with this colored paper. This means that the paper used to cover the ice cream will be equal to its total surface area. Do you remember the formula for the total surface area of the cone, Thomas?
The total surface area of the cone is equal to the product of pi r and the sum of r and l, where r and l are the radius of the base of the cone and its slant height respectively.
The radius of the ice cream base is 2 centimeters and its slant height is 12 centimeters. Let me solve this by writing this measure here instead of R and L respectively.
Look, Manas, the cone has a total surface area of 88 square centimeters. This means 88 square centimeters of paper has been used to cover the ice cream completely.
Oh wow, Thomas! Let us return to our world now. I hope our ice creams haven't melted.
Both the friends ate their ice creams with a lot of fun. Friends, in this video, we saw another interesting example based on the surface area of right circular cone. So hopefully now you have got a good understanding of the surface area of a right circular cone. Hello friends, welcome to this video. Today in this video we will study about the surface area of sphere and hemisphere.
Thomas, look what I have brought for you today.
This looks so beautiful. What is this, Manas?
Sweets from my sister's wedding. You know, Manas, this sweet is completely coated with silver.
Oh wow! How much silver would have been used to cover it?
We can find the answer to this through mathematics. That means it's math time!
Manas, this sweet is circular, isn't it?
No, Thomas. This is a sphere.
Now, what is this sphere?
Thomas, just like a circle is a two-dimensional shape, a sphere is a three-dimensional solid shape, which is made up of all those points in space which are at a certain fixed distance from a certain fixed point. This fixed point is called the center of the sphere, and the fixed distance is called the radius of the sphere.
Alright, I understood about the sphere, but how will we find out the amount of silver used to cover this spherical sweet?
The silver is completely covering the total surface of the spherical sweet. So we can say that the silver used to cover the spherical sweet will be equal to the surface area of this sphere.
You're right. But how do we find the surface area of the sphere? We do not know its formula.
Then let us find the formula for the surface area of a sphere. Suppose the radius of this spherical sweet is r. Now imagine if we wrap a string on this sphere in this way and keep wrapping it on the sphere till it covers the sphere completely. Now on a paper, if we make 4 circles with radius r of the sphere in this way and fill the circles by placing the string we had wrapped the spherical sweet with one by one, then we will find that the string which completely covered the surface of the sphere is now filling the surfaces of 4 circles with same radius as that of the sphere. Can you tell me what this means?
I get it. This means the surface area of a sphere with radius r is equal to the area of 4 circles with radius r, and the area of a circle of radius r is pi times r square. Oh wow, Manas! We found the formula for the surface area of a sphere. The surface area of a sphere is 4 times pi r square, where r is the radius of the sphere.
Well done, Thomas. But what are you thinking now?
I am thinking that I will surely eat this sweet by sharing it with you. But if we cut it into 2 equal parts, what will this new shape be now?
Thomas, if we take any solid sphere and cut it into 2 parts by passing a plane through its center, then it will be divided into 2 equal parts, and each half of this is called a hemisphere.
Now, what will be the formula for the surface area of this hemisphere?
I will tell you. First, you tell me how many surfaces are there in this hemisphere?
2. One is curved and the other is flat.
That's correct. The area of this curved surface is equal to the curved surface area of the hemisphere. As you can see, the curved surface area of the hemisphere is half of the surface area of the sphere. That is, the curved surface area of a hemisphere is equal to the product of 2 pi and r square, where r is the radius of the base of the hemisphere.
And look, if we add the area of the flat surface to the curved surface area of the hemisphere, then we will also know the formula for the total surface area of the hemisphere. In this way, the total surface area of the hemisphere is the product of 3 pi and r square. Let me quickly write these formulae in the formula booklet.
You forgot all about your original question in the whole sphere and hemisphere discussion. Come on, now quickly find out how much silver has been used to cover this spherical suite.
Oh yes. I will solve this quickly by writing the radius of the spherical suite. 3.5 centimeters instead of r in the formula for the surface area of this sphere. Look, this spherical suite has been covered with 154 square centimeters of silver.
Well done, Thomas. Now let's quickly return to our world and eat this sweet by dividing the sphere in half.
The two friends enjoyed eating the sweet by dividing the spherical sweet into halves. In this video, we studied about the surface area of sphere and hemisphere. We learned 1. What is a sphere and hemisphere? 2. How to find surface area of sphere and hemisphere. In the next video, we will see some interesting examples based on this. Hello friends! Welcome to this video. In the previous video, we studied about the surface area of sphere and hemisphere. Now, in this video, let us look at interesting examples based on the surface area of sphere and hemisphere.
You have made very beautiful models of the moon and the earth. The moon and earth are both spherical, right?
Yes, Thomas.
But Manas, have you used more clay to make the model of the earth or to make the model of the moon?
I don't know, Thomas. Why don't we find the answer to this through mathematics? That means it's math time! Look, Thomas, the models of both the moon and the earth are hollow spheres. The radius of the moon's model is 35 centimeters and the radius of the earth's model is 140 centimeters.
I remember the formula for the surface area of sphere. The surface area of sphere is 4 times pi r square, where r is the radius of the sphere. And because both of these models are hollow spheres, the amount of clay used to make them will be equal to their surface areas. Let me solve this by writing the radius of the moon's model 35 centimeters instead of r first. Manas, the surface area of the model of the moon is 15,400 square centimeters.
Okay, now it's my turn. I will solve it in this way by writing the radius of the model of the earth 140 centimeters in the formula for the surface area of the sphere. Look, the surface area of the earth's model is 2,46,400 square centimeters.
The clay used in the model of the earth is many times more than the model of the moon.
And do you know another fun fact? If we find the ratio of the clay used in the model of the moon and the clay used in the model of the earth in this way, then you can see that their ratio is 1/16. And in fact, the ratio of the surface area of the moon and the earth is also 1/16. Isn't it amazing?
It is. This is really interesting. Let us quickly return to our world. Then you tell me more information about the moon and the earth.
With this example, we have seen how our daily life problems can be solved based on the surface area of the sphere and hemisphere. In the next video, we will see some more interesting examples based on this. Welcome to this video. In the previous video, we saw an interesting example based on the surface area of sphere. Today, in this video, we will look at some fun examples based on surface area of hemisphere.
Manas, let us go to the fair.
No, I will not be able to come. Mom has asked me to get these bowls galvanized from the utensils shop.
Good. What will be the cost of getting galvanization done on these bowls?
I never thought about it. The shopkeeper charges 5 rupees per square centimeter for galvanization. But how do I find out how much it will cost to get these 2 bowls galvanized?
We can find the solution to this through mathematics. That means it's math time! Look, every bowl is a hemisphere. And because we have to get the inner surface of each bowl covered, the surface of each bowl will be equal to its internal curved surface area.
Oh, is it? I can easily find this. These 2 bowls are exactly the same. So, their internal curved surface area will also be equal. The bowl is a hemisphere and has an internal diameter of 14 centimeters. This means the internal radius of each bowl is 7 centimeters. But there is a problem. I do not remember the formula for the curved surface area of the hemisphere.
Oh, this is very easy. Let me show you an easy way to remember this. These bowls are hemispheres, and every hemisphere is half of a sphere. Therefore, the curved surface area of hemisphere will be equal to half of the surface area of a sphere. That is 4 pi r squared divided by 2. In this way, the curved surface area of the hemisphere is a 2 pi r square, where r is the radius of the hemisphere.
Oh yes! Thanks, Thomas. Let's solve this by writing the radius of the bowl 7 centimeters instead of r. The internal curved surface area of the bowl is 308 square centimeters.
That's right. And you have 2 such bowls. This means you have to get a total area of 2 times 308, that is 616 square centimeters. Now we just need to multiply the galvanization rate per square centimeter, 5 rupees, by total surface area to be galvanized, 616. Look, Manas, it will take a total of 3080 rupees to get the galvanization done.
Oh God! So much money! It was good that you told me, Thomas. I was going to the shop only with 100 rupees.
Let us return to our world now. I will quickly take you to the market on my bicycle. After that, we will both go to the fair.
Friends, in this video, we saw a fun example based on the surface area of hemisphere. We hope you have a good understanding of the surface area of sphere and hemisphere now. Hello friends, we welcome you all to this video. Today in this video, we will study the volume of cube and cuboid.
Thomas, did you bring the paper for the project?
Yes, look, I have brought both square and rectangle papers for the project.
Thomas, did you notice that square-shaped paper packets and rectangle-shaped packets are taking up different spaces?
Yes, that is because the volume of a packet of square-sized papers and the volume of a packet of rectangle-sized papers are different.
I did not understand what you meant. Thomas, can you please explain this to me in more detail?
Absolutely. Let me explain this to you through mathematics. That means it's math time. Let's look at these rectangular paper packets first. Suppose the area of each rectangular paper is A and the height to which the stack of rectangular papers is stacked is H. Can you tell me of what shape are these rectangular paper stacks?
It is a cuboid shape. The area of the base is A and the height is H.
Right. And you already know that the space enclosed by any object is called its volume. Therefore, we can say that the space occupied by these cubical paper packets is its volume, V. And you can see that this volume is equal to the product of the area of each rectangular paper A and the height of the stack H. Look, we have come to know the formula for the volume of any cuboid. We can measure the volume of any cuboid as the area of its base multiplied by its height. Or, in other words, we can write it as the product of its length L, breadth B, and height H.
Oh yes, Thomas. Now, let's look at this cubical paper packet. Every cube is a special type of cuboid. It is special because all of its edges are of the same size. So, if we assume that every edge of this cube-shaped paper packet has a measure of A, we will get the formula of volume of cube of A.
Aha, you understood this very quickly, Manas. Now, let's first measure the length, breadth and height of this cubic paper packet and replace the values in the formula of a cuboid. Its length is 21 centimeters, breadth is 30 centimeters and height is 5 centimeters.
And on solving it in this way, we can see that the volume of this cuboid-shaped paper packet is 3150 cubic centimeters.
Now, I will find the volume of these cube-shaped paper packets. Here, I measure any one of the edge of this cubic paper packet and insert its value in the formula for the volume of a cube. Let me write 21 centimeters. Now, by solving in this way, we can see that the volume of the cube-shaped packet of paper is 9,261 cubic centimeters.
Now I understand it, Thomas. Look, the volume of the cube-shaped packet of square paper is much more than the packet of rectangular paper.
You are right, Manas. Let us quickly return to our world. We also have to complete the project. Let's finish the project together.
The two friends together completed those projects using the square and rectangular papers. In this video, we studied the volume of cube and cuboid. We learnt 1. What is volume? 2. How to find the volume of a cube and a cuboid. In the next video, we shall see some interesting examples based on this. Hello friends! All of you are welcome to this video. We had studied the volume of cube and cuboid in the previous video. Now, in this video, let us look at some interesting examples based on volume of a cuboid.
Manas, why is this wall built on the right side of your house?
Rats from the neighboring farm have been terrorizing us since a few days. So my dad built this wall between our house and the farm.
This wall is very high. How many bricks would have been used to construct it?
Let's figure this out by counting the bricks.
Oh, no. We can find this easily through mathematics.
Oh, great! That means it's math time!
Look, Manas, the wall is cuboid in shape and the space that is occupied by it, that is, the volume of this cuboid, is equal to the space occupied by all the bricks. So let's first find the volume of the wall. Can you tell me what is the length, breadth and height of this wall?
The length of the wall is 7 meters, its width is 21 centimeters and the height of the wall is 4 meters.
Now, we know that the volume of the cuboid is the product of L, B and H, where L, B and H are its length, breadth and height respectively. First, we will write all these measurements in the same unit, centimeters, in this way. Now, we can write the length, breadth and height of this wall over here in this formula instead of L, B and H respectively. Now can you write the volume of each brick in the same way?
Absolutely! Each brick is cuboid in shape, having 21 centimeters, 14 centimeters and 8 centimeters as the length, breadth and height respectively. Now I will write the length, breadth and height of the brick in the formula in this way instead of L, B and H to find the volume of the cuboid brick.
Well done, Manas! Now, to find the number of bricks in the wall, we only have to divide the volume of the wall by the volume of each brick.
Thomas! On solving this, we can see that 2,500 bricks have been used in the wall. this was done very quickly and easily instead of wasting a lot of time in counting each brick.
Yes. Let us now return to our world and paint this wall with a beautiful color, due to which this wall will start to look more beautiful.
The two friends together painted the wall in a beautiful blue color. With this example, we have seen how some of our daily life problems can be solved by understanding the volume of a cuboid. In the next video, we will see some interesting examples based on the volume of a cube. You are all welcome in this video. In the previous video, we have seen an interesting example based on the volume of a cuboid. Today, in this video, we will look at some more interesting examples based on the volume of a cube.
Happy birthday, Manas! Wish you many happy returns of the day.
Thank you, Thomas. Look, my mother has baked such a beautiful cake for me.
Yes, Manas. I have never seen a cube-shaped cake before.
Thomas, can you help me? I have to cut this cubic cake into 8 equal pieces. I want the pieces to also be cubic, but I'm unable to find out how much will be the length of each side of the smaller cubes that would all be of equal volume.
It's so easy. Let me explain this to you through mathematics. So, it's math time! Manas, because we are cutting this cubic cake into 8 cubes of equal volume, we will firstly need to find the volume of each piece. We can then easily find the volume of each smaller cube by dividing the volume of this entire cubic cake by 8. That way, we will get what we need. So, let's first find the volume of this cubic cake.
Okay, I will find it quickly. The cake is cubic and its edges measure 12 centimeters. And as we know that the volume of any cube is equal to the cube of L, where L is the measure of the edges of the cube. So, if I replace L here with the actual measure of the edges of the cubic cake, that is 12, then by solving it in this way, by writing 12 centimeters, we can see that the volume of a cubic cake is 1728 centimeters cube.
Good. Now, if we divide the total volume of this cake by the total number of pieces, 8, we will know the volume of each cubic piece. Look, the volume of each smaller cube cake is 216 centimeter cube.
Now we have also come to know the volume of each piece of cake. But now how will we find the length of the edge of each cubic piece?
It's simple. Because the volume of a cube is the cube of its side. Therefore, the measurement of the side of a cube will be the cube root of its volume. Here, the volume of each cubic piece is 216 centimeter cube. If we write this here instead of the volume of the cube, in this way, we can easily find the length of the edge of each piece. See? Find the length of the edge of each cubic piece is 6 centimeters.
Thanks, Thomas. Let us quickly return to our world. I will cut this cake into 8 cubed pieces with a 6 centimeter each, and then we will enjoy it together with the rest of our 6 friends.
Manas cut the cake into 8 cubes and the 2 friends went to share the cake with their other friends. Friends, in this video, we saw an interesting example based on the volume of a cube. So hopefully you will now have gotten a good understanding of the volume of a cube and a cuboid. Hello friends, welcome to this video. Today in this video, we will study volume of right circular cylinder.
Look, I'm making candles for Christmas preparation today.
These are so wonderful and beautiful. How many candles are you going to make, Thomas?
I am thinking that I will make 20 such candles so that I can decorate the whole house with them.
Oh, wow! But you will need a lot of wax to make so many candles.
Oh yes, I had not thought about it. But how do I find out how much wax I will need to make 20 candles?
Oh, come on! Just as we find solutions to other problems through mathematics. That means it's math time! Look, Thomas, each candle is a right circular cylinder. The amount of wax used to make each candle will be equal to the space it occupies, that is, its volume.
In the previous standard, we learned the formula for the volume of right circular cylinder. But I don't remember it now. Do you remember the formula?
I don't remember this formula either. But we can find it again. Each candle is a right circular cylinder because its curved part is perpendicular to its base. Imagine that each candle is made of thin circular layers of negligible thickness, and the radius of each circular layer is r. Now, if the height of each candle is h, then we can say that the space enclosed by each candle, that is, its volume, will be equal to the area of each circular layer multiplied by its height. The area of each layer is equal to pi r square, and here the height of the candle is h. Therefore, we can say that the volume of the right circular cylinder is equal to pi r square h, where r is the radius of the base and h is the height of the right circular cylinder.
Oh wow, Manas! We found the formula for the volume of a right circular cylinder. Now, I will solve this by writing the radius of the base of the candle 3 centimeters in place of r and the height of the candle 14 centimeters in place of h. The volume of each candle is 396 cubic centimeters. This means I would need 396 cubic centimeters of wax to make each candle. And I want to make 20 such candles. For this, I will need 396 times 20. That is 7,920 cubic centimeters of wax.
Let us go back to our world and buy wax from the market. Then we will make candles together.
The two friends made 20 candles together and decorated Thomas's house with those candles. In this video, we studied about the volume of right circular cylinder. We learned 1. What is the volume of right circular cylinder? 2. How to find volume of right circular cylinder. In the next video, we will see some interesting examples based on this. Hello friends, welcome to this video. In the previous video, we studied about the volume of right circular cylinder. Now, in this video, let us look at interesting examples based on volume of right circular cylinder.
Thomas, here, have some orange juice. My mother made it for this evening's party.
This is delicious, Manas.
Yes, Mother has filled this pot completely with orange juice for the party.
How much juice would there be in this pot?
I don't know this, but we can definitely find the answer through mathematics. That means it's math time! Look, Thomas, this vessel is a right circular cylinder because its curved part is perpendicular to its base. And because the vessel is completely filled with juice and the thickness of the pot is negligible, the space occupied by the juice in the vessel is equal to the space occupied by the vessel. In other words, the volume of the juice is equal to the volume of the vessel.
And I now remember the formula for the volume of a right circular cylinder very well. The volume of a right circular cylinder is pi r square h, where r is the radius of the cylinder's base and h is its height.
Well done, Thomas! Now, for solving this, we will just replace r and h in this formula with the radius of the base of the vessel 15 centimeters and height of the vessel 35 centimeters respectively. Look, Thomas, the volume of the vessel is 24,750 cubic centimeters. This means that the volume of the juice filled in the pot is also 24,750 cubic centimeters.
But Manas, this is in cubic centimeter and we measure juice in liters, don't we?
Yes, Thomas. See, 1 cubic centimeter is equal to 1 milliliter. Therefore, we can say that the volume of juice is 24,750 milliliters. And because 1000 milliliters is equal to 1 liter, the volume of the juice is 24,750 divided by 1000. That is 24.75 liters.
Wow! Let us go back to our world. There are just a few hours left for the party to start. You also have to help Mother. I will help you too.
The two friends together did all the preparations for the party. With this example, we have seen how our daily life problems can be solved based on volume of right circular cylinder. In the next video, we will see some fun examples based on this. Welcome to this video. In the previous video, we saw an interesting example based on volume of right circular cylinder. Today, in this video, we will see some fun examples based on volume of right circular cylinder.
Thomas, will you come to the market with me? My mother has asked me to buy a tap.
Yes, let's go.
Uncle, please give me a tap.
Here you go. Uncle, you seem a bit upset. What is the matter? Actually, I want to make an iron pipe. I know its inner diameter is 2 centimeters, outer diameter 2.5 centimeters and length 35 centimeters. And I also know that the mass of 1 cubic centimeter of iron is equal to 7 grams. But I can't find out how much iron will I need to make the pipe.
Thomas, we can find the solution to Uncle's problem through mathematics. That means it's math time! Look, Thomas, because the pipe has some thickness, so it has 2 diameters. The iron required to make the pipe is occupying the space between its internal and external surfaces. Therefore, we can find the iron used to make the pipe by subtracting its internal volume from its outer volume.
Yes, Manas. And see, both the inner and outer surfaces of the pipe are right circular cylinders because their curved parts are perpendicular to their circular base.
Absolutely right, Thomas. We can write the volume of the inner right circular cylinder of the pipe as pi r1 square h, where r1 is the radius of the inner base of the cylinder and h is its height. And we can write the volume of the outer right circular cylinder of the pipe as pi r2 square h, where r2 is the radius of the outer base of the right circular cylinder and h is its height. As I told you earlier, the iron used to make the pipe is equal to the difference between the volumes of its outer and inner right circular cylinders. The diameter of the inner right circular cylinder part of the pipe is 2 centimeters. That is, its radius will be 1 centimeter. And the diameter of the outer right circular cylindrical portion of the pipe is 2.5 centimeters. This means its radius will be 1.25 centimeters. Let us now write the radius of the inner cylindrical part 1 centimeter instead of R1 and radius of outer cylindrical part of the pipe 1.25 centimeter instead of R2 respectively. And then also write the height of the pipe 35 centimeters instead of h.
Now it's my turn. I will solve it quickly in this way. We know that 1 cubic centimeter of iron is equal to 7 grams. Therefore, the mass of iron used in the pipe is 61.875 times 7. That is 430 433.125 grams. Look, Manas, Uncle needs 433.125 grams of iron for the pipe.
Haha, come on Thomas, let us quickly return to our world. Uncle will be waiting for us.
The two friends told Uncle the amount of iron needed to make the pipe. On knowing this, Uncle thanked both of them and appreciated their intelligence. Friends, in this video, we saw a fun example based on volume of right circular cylinder. So hopefully, now you have a good understanding of volume of right circular cylinder. Hello friends, you are all welcome to this video. Today, in this video, we will study the volume of a right circular cone.
Look, my mother has brought me this unique shaped vessel.
It is a right circular cone. How much water can you fill in this, Thomas?
I don't know. If it was a right circular cylinder, I would have answered it quickly. But how can we find the volume of a vessel that's in the shape of a right circular cone?
It is very easy. Let me teach you the formula of volume of right circular cone by using the volume of a cylinder.
Hey, wow! That means it's math time!
Thomas, can you bring a cylindrical vessel whose height and radius of the base are equal to this right circular conical vessel?
Of course, I'll bring it right away. Here, take this, Manas.
Thomas, now we will first fill this long circular conical vessel completely with water up to the brim and pour this water into this cylindrical vessel. Look, Thomas, some part of the cylindrical vessel has been filled with the water. Now, we will again fill the conical vessel completely with water and pour it into the cylinder. As you can see, the cylinder is still not fully filled. Now, we will fill the cone with water for the third time and pour it into the cylinder.
Hey, look! The cylinder is completely filled with water.
Yes, Thomas. So we can conclude that the volume of 3 cones is equal to the volume of a cylinder. This means if the radius of the base and the height of the cone and cylinder are the same, then the volume of the cone is 1/3 of the volume of the cylinder. And you know that the volume of a circular cylinder is equal to the product of the pi square of r and h, where r is the radius of its base and h is the height. Therefore, we can write the volume of the right circular cone as 1/3 of the volume of the cylinder, where r is the radius of the base of the cone and h is its height.
Hey, wow! Manas, let me quickly write the formula for the volume of a right circular cone in the formula book.
Thomas, because the thickness of your conical vessel is very small, we can treat it as negligible. The amount of water that is encased in this conical vessel will be equal to its volume. So, now we just need to find the radius of its base in the formula for this right circular cone. the radius is 3 centimeters and its height 14 centimeters. So, let us solve this by replacing the numbers at the places of R and H respectively. And then we will know the volume of this right conical vessel.
The volume of a long circular conical vessel is 132 cubic centimeters. And we know that 1 milliliter is equal to 1 centimeter cube. Therefore, we can say that 132 milliliters of water can be filled in this right circular conical vessel.
Let us go back to our world, Thomas. Then, as a way of thanking your mother, we will set ice cream for her in this conical vessel.
In this video, we studied the volume of a right circular cone. We learned 1. What is volume? 2. How to find volume of a right circular cone. In the next video, we will see some interesting examples based on this. Hello friends, we welcome you all to this video. We had studied the volume of a right circular cone in the previous video. Now, in this video, let us look at interesting examples based on volume of right circular cone.
Look, Thomas, a new building is being built here.
Yes, Manas. Look, that uncle just poured a sack of sand on the floor. And if you look closely, you will find that this sand is making a cone on the ground.
Yes, Thomas, this is really conical in shape. Can you tell me approximately how much sand was in the sack?
It's so easy. Let us find the answer through mathematics.
That means it's math time!
Look, Manas, Uncle has poured a sack full of sand on the ground. It's a conical pile of sand. And you already know that the space enclosed by any object is equal to its volume. This means that the amount of sand in this pile, or in other words, a sack, is equal to the volume of the pile of this conical sand.
I remember the formula for the volume of a cone. The volume of any right circular cone is 1/3 the product of pi square of R and H, where R is the radius of the base of the cone and H is its height. But Thomas, this is a difficult one. We can see that the height of this sand pile is perpendicular to its base, so it is a right circular cone. And we can also find the radius of its base by measuring the diameter of its base. But we cannot measure its height. So, how can we find its volume?
Don't you remember, Manas, that according to the Pythagoras theorem, the square of the diagonal height L of any perpendicular circular cone is equal to the sum of the squares of the radius of its base R and the height H.
Oh yes, and we can measure the diameter of the base of this conical sand pile and also the slant height. Let me quickly measure them. The diameter of the base of this conical sand pile is 42 centimeters and its slant height is 29 centimeters.
Because the diameter of the base of the conical sand pile is 42 centimeters, the radius of its base will be half of 42 centimeters. That is 21 centimeters. Let us now replace L as the slant height and R as the radius respectively. The slant height of the sand pile 29 centimeters and the radius of its base is 21 centimeters. Look Manas, we should solve it in this way and find the height of the conical sand pile. Got it? The answer is 20 centimeters.
Oh wow! Now let me quickly replace R and H in this formula respectively. The radius of the conical pile of sand is 21 centimeters and we solve to get the height, which is 20 centimeters. Thomas, we got our answer. A bag of sand has 9,240 cubic centimeters of sand.
Well done. Now let us return to our world. Then we will go to play at your house.
With this example, we have seen how our daily life problems can be solved based on the volume of a right circular cone. In the next video, we will see an interesting example based on this. You are all welcome in this video. In the previous video, we have seen an interesting example based on volume of a right circular cone. Today, in this video, we will see some interesting examples based on volume of right circular cone.
Thomas, why have you dug up this huge conical pit?
I made this to feed the birds.
Oh, wow! But how much water can you fill in it?
Let's try to find out. We can find the answer through mathematics. It's math time! Look, this pit is conical in shape. The amount of water it can fill is equal to its capacity. And its capacity will be equal to the internal volume of the pit. Therefore, we only have to find the internal volume of the pit.
I can quickly find the answer. The upper diameter of the conical pit is 12 centimeters. That means its radius is 12 divided by 2, which is 6 centimeters. The depth of the pit is 20 centimeters, which is also equal to the height of this conical pit. And as you know, because the height of this pit is perpendicular to its base, we can say that this pit is a right circular cone. Now, all we need to do is replace the values of the radius of the right circular cone R, which is 6 centimeters, and its height H, which is 20 centimeters, in the formula for the volume of a right circular cone.
Look Manas, the internal volume of the pit is 754.28 cubic centimeters. And we know that 1 centimeter cube is equal to 1 milliliter. Therefore, we can say that the capacity of the pit is 754.28 milliliters.
That is a lot of water. Thomas, let us quickly return to our world. By now, many birds must have gathered to drink water from your pit.
Both the friends were very happy to see many colorful birds drinking water from Thomas's pit. Friends, in this video, we saw an interesting example based on volume of a right circular cone. So hopefully you will now have a good understanding of the volume of a right circular cone. Hello friends, welcome to this video. Today in this video, we will study the volume of sphere and hemisphere.
Manas, this time I will surely hit a 6.
On saying this, Thomas swung the bat and the ball fell straight into a vessel filled with water.
Oh no, Thomas! Look! Your 6 has spilled a lot of water on the table here. Now, who will wipe it?
I will wipe it if you answer one of my math questions.
Ha! Done.
Can you tell me what is the volume of this ball?
This is very easy. Let me tell you the answer through mathematics. That means it's math time. First, we will fill this pot once again completely with water. Also, we will take a big container in which we will keep this vessel. And we will also need a measuring cylinder. Now look, I will put this ball carefully in this pot.
Again?
Yes, don't panic. As you can see, some water has come out of the vessel and collected in the big container. Now can you tell me its volume by carefully pouring the water filled in this container into this measuring cylinder?
It's about 180 milliliters.
Alright. Now look, Thomas. The radius of the ball is 3.5 centimeters. Can you find the value of 4 by 3 product of pi and the cube of the radius of the ball?
Absolutely. See how I solve it quickly. Hey, what is this? This is equal to 179.67. That is approximately 180 milliliters. Why so?
This is because the ball occupies some space in this vessel. The amount of space the ball occupies in this vessel is the amount of water spilled from the vessel and deposited in the container. And as you know, the space occupied by any object is equal to its volume. Therefore, the volume of the ball is equal to the measure of the water spilled from the vessel. And look, Thomas, the ball is spherical. And you have just seen that its volume is equal to the value of the product of 4 by 3 pi and the cube of the radius of the ball. If we assume that the radius of a spherical ball is r, then we can write the formula of volume of sphere in this way.
Hey, wow, Manas! The hemisphere is half of sphere, is it not? This means that we can write the formula of volume of hemisphere in this way by dividing the volume of the sphere by 2. where r is the radius of the hemisphere. Oh wow! Let me quickly write both these formulae in the mathematics formula book.
Look, Thomas, I have given you 2 new formulae along with the answer to your question. Come on, now let's go back to our world. And because you lost the bet, you have to wipe the water on the table too.
In this video, we studied the volume of sphere and hemisphere. We learned 1. What is volume? 2. How to find volume of sphere and hemisphere. In the next video, we will see some interesting examples based on this. Hello friends, welcome to this video. In the previous video, we studied about the volume of sphere and hemisphere. Now, in this video, let us look at interesting examples based on volume of sphere.
Look, Thomas, I brought this perfume bottle for Mother's birthday.
Oh wow, Manas! Its scent is really very good. How much perfume will be there in this bottle?
We can find the answer to this through mathematics.
Alright, that means it's math time!
Thomas, the part of the perfume bottle in which the perfume is filled is spherical. And because the bottle is made of thin glass, we would consider its thickness to be negligible. Therefore, the space occupied by the perfume in the bottle is equal to the space occupied by the bottle. In other words, the volume of the perfume will be equal to the volume of the spherical bottle. Do you remember the formula for the volume of the sphere?
Absolutely! The volume of a sphere is equal to the product of 4 by 3 pi and r cube, where r is the radius of the sphere.
Well done, Thomas! Now, to solve this, just replace r in this formula by the radius of spherical bottle, 4.9 centimeters.
Alright, the volume of spherical bottle is 493 cubic centimeters. And because 1 cubic centimeter is equal to 1 milliliter, we can say that 493 milliliters of perfume is filled in the spherical bottle.
Thomas, let us quickly return to our world. I also have to give this gift to my mother.
The two friends celebrated Manas's mother's birthday with great enthusiasm. With this example, we have seen how our daily life problems can be solved based on volume of sphere. In the next video, we will see some fun examples based on volume of hemisphere. Welcome to this video. We have seen in the previous video how our daily life problems can be solved based on the volume of a sphere. Today, in this video, we will see some fun examples based on volume of hemisphere.
Oh wow! Today there is yogurt being served with food in the canteen. I have been told by my mother to eat at least 100 grams of curd every day.
That's a very good thing, Manas. Will this bowl contain more than 100 grams of curd?
I don't know this, but we can definitely find the answer through mathematics. That means it's math time! Look, Thomas, the bowl is semi-spherical and the amount of space occupied by the curd in it will be equal to its internal volume. So, first we have to find the internal volume of this bowl.
The internal diameter of the bowl is 8.4 centimeters. This means that its internal radius is half its internal diameter, or 4.2 centimeters. The formula of volume of hemisphere is equal to the product of the 4 by 2 by 3 pi and cube of r, where r is the radius of the hemisphere. Now I can solve this by replacing the inner radius of the bowl as 4.2 centimeters here instead of r. The internal volume of the semispherical bowl is 155.23 cubic centimeters. And because 1 cubic centimeter is equal to 1 milliliter, we can say that the internal volume of the bowl or the volume of yogurt is 155.23 milliliters. Manas, we came to know the internal volume of the bowl or the volume of the curd. But how do we find the mass of curd from it?
Mass is the product of volume and density. We know the volume of curd, and we also know that the density of curd is about 1 gram per milliliter. So, writing the volume of yogurt 155.23 milliliters and density 1 gram per milliliter will give us the mass of the curd. Look, Thomas, we got our answer. The bowl has 155.23 grams or about 155 grams of curd.
Oh wow, Manas! And this is more than 100 grams. This means that you can follow your mother's instructions by eating a bowl of yogurt every day.
Absolutely! Now let's go back to our world and then you too eat a bowl of yogurt with me daily so that both of us stay healthy forever.
Friends, in this video, we saw a fun example based on volume of hemisphere. So hopefully you now have a good understanding of the volume of sphere and hemisphere.